Hello everybody, welcome to another session of Database Management System, which is the BSc 5th Sem paper. Myself, I am Vaishali and I am faculty of Vignan Degree College, and in today's module I am going to discuss about the second unit, Entity Relationship Data Model, in which the topics include generalization, specialization, attribute inheritance, multiple inheritance, aggregation, composition and entity clustering. Let us now discuss about each and every one in detail. The module outline would be like this: generalization, specialization, inheritance, multiple inheritance, attribute inheritance, aggregation, composition and entity clustering. Now let us discuss about one by one in detail. Let us start our discussion with generalization. So what is generalization and specialization? Generalization, it is a data modeling process of defining more general entity types from a set of specialized entity types. From a set of specialized entity types, we generate a general entity type. Thus it is a bottom-up process. Let us now learn in detail about this definition by considering an example. Let us here in our example consider three entities, namely car, truck and motorcycle. Let us consider three entities, which are car, truck and motorcycle. At this stage, for three entities, we are going to draw three diagrams, for which in the car we have attributes which include vehicle number, vehicle name, vehicle price, car model, etc. Truck include truck number, vehicle ID, vehicle name, vehicle price, vehicle capacity, etc. For motorcycle, it includes vehicle ID, vehicle name, vehicle price, and also its capacity. Like that, I am going to consider three diagrams for three entities, car, truck and motorcycle, among which if we observe carefully, there are some attributes which are common among these three entities, which include vehicle ID, vehicle name and its price. Let us now see them with the help of this diagram. Consider the car, which is being surrounded by the attributes vehicle ID, vehicle name, passengers and its price. In the truck we have vehicle ID, price, vehicle name and its capacity. For motorcycle I have vehicle ID, vehicle name, its model and its price. If we look over all the three attributes, if we look over all the three entities, there are certain attributes which are common among the three entities, which include what are the attributes that are common for all the three? Vehicle ID, vehicle name and its price. They are common for all the three entities. Such entities which are common, such attributes that are common for all the three entities are being brought out and they are being placed separately in one entity, and separately a new entity is defined for it, which is called as the process of specialization. It is called as the process of specialization. So the more general entities, such more general entity types together with resulting the super type or subtype relationship, which is shown in the following diagram. So I am going to divide this diagram and I am going to represent all these three things in only one diagram. Let us see that diagram. See, now if I consider vehicle, which I am going to consider it as an entity super type, in which I am going to consider the attributes are vehicle ID, price and vehicle name, followed by the subtypes as car and truck. Car has its own attributes, truck has its own attributes which are specialized for them. The car entity has some specific attributes, passengers, while the truck entity has the specific attribute called as capacity, which are common only, which these attributes are. These passengers is specialized attribute of a car and this capacity is specialized attribute of truck, wherein which the common attributes for car and truck are being included into the vehicle. So this is called as a generalization process. This generalization process allows us to group entity types along with its common attributes. So this is an entity type in which I am going to group the common attributes and I am going to retrieve these attributes into our subtype classes. This is what generalization means. Next, moving on to the next one, specialization. What is specialization? So the opposite to generalization is something which is opposite to generalization can be told as specialization. So it is a data modeling. In this data modeling, specialization is a process of defining one or more subtypes of supertype and forming a supertype or subtype relationship. So let us again now consider here an example and know what is specialization. For that I am going to consider an example here, an entity naming parts, which has part number, part name, its quantity, its price and its supply. A part is an entity in which we have various attributes which include part number, part name, quantity, supplier and its price. Each subtype is formed on some distinguishing characteristics, some different characteristics, such attributes or relationships up to the subtype. In our example, part is an entity type which has different attributes. Among the different attributes, part number is called as an identifier or the key attribute, and it includes the other attributes which include part name, part price, quantity and supplier. Now let us think, if let us go in detail into this. These parts are being here again divided. In the parts we have two types to be discussed. So in our discussion with the users, we discovered that there are two possible sources from parts. The parts can be divided internally into two categories. What are those? The parts that are manufactured internally and the parts that are being obtained from outside, are being supplied from the other person. So the parts is again divided into two categories, that is manufactured parts and the purchased parts. That is, a part can be manufactured by myself, or if I cannot manufacture that part, I can order it from outside and I can purchase it. So the part here is a super type which is internally divided into subtypes. Manufactured parts and purchased parts. Here the part is called as the super type entity, wherein which this is being again divided into subtypes, manufactured parts and purchased parts. The super type entity has some common attributes, part number, part name and its quantity, whereas manufactured parts has its own attributes, routing number, and the purchased parts has its own attributes, price. These factors suggest that part number should be specialized by defining subtypes, manufactured parts and purchased parts. So this is how I define the other one, which is called as generalization. This is the general definition of generalization. So from these both, I am going to give the definition of the attribute inheritance. What is attribute inheritance? Specialization is opposite to generalization. So before going to define about attribute inheritance, let me tell that specialization and generalization are opposites to each other. From one super type, if I derive subtypes, it is called specialization, and from one subtype, if I generally define a super type, it is called as generalization. So in generalization, a group of entities are divided into subgroups. From a group of entities, I am going to generate a subgroup. It is called as specialization. For example, take a person, a example group called as person. A person can have name, date of birth and gender. These are the common properties for every person. So these persons include human beings. These persons can also be called as human beings. Now, if I consider a company with number of persons, consider a company which has number of persons. Here the persons are again divided into various categories. The person here again is divided into or being identified as an employee, employer, customer, vendor, based on the type of job he performs in the company. Based on the type of a job performs, the person here is being divided as a, or can be divided as an employee, employer, customer or vendor. Person by itself is only one entity. It contains a group of employees working in a particular company. Again, based on the type of job, the person is being divided into four, can be categorized into 4 or 5 categories based on the type of job. Now, if I consider the person, he can be, or a person is a student, or a person is a teacher. In our example, a person is an employee, a person is an employer, a person is a customer, a person is a vendor. One more example for this is, if we consider a school database which has number of persons inside it, the persons can be, or a person is a teacher, or a person is a student, or a person is a staff, based on the type of job he does in the school. This is about attribute inheritance. Now, based on this inheritance, I can get the definition of inheritance. So, what is inheritance? We use all the above features of ER model in order to create class of objects in object-oriented programming. So, number of objects put together, it can be defined as a class. That is what I have written. Number of objects here. A student is an object, a teacher is an object. All these objects put together, I am going to generate a person which is a class. The details of these entities are generally hidden, which is a process of data abstraction. So, the student roll number is being hidden. The teacher employee ID is being hidden. This way of hiding the specialized features of a student and the teacher is called as abstraction. Inheritance is an important property of generalization and specialization, which provides us with this property of abstraction. It provides us abstraction, that is, it helps us to avoid unauthorized access. It allows the lower level entities to inherit the higher level entities. All the properties of the higher level entities are being inherited into the lower level entities. For example, the person is a higher level entity in which the the attributes are name, age, and gender. These properties of a person can be inherited into a student, or they can be inherited into a teacher. So that way of inheriting the properties from the supertype into the, or getting the properties from a superclass into the subclass is called as inheritance, wherein which the roll number is restricted only, the roll number attribute is restricted only for this student, and the employee attribute is restricted only for this teacher. This is the representation of inheritance, followed by association, aggregation, and composition. So what is association, what is aggregation, and what is composition? So association, first one, association is nothing but the relation that is being established in between the entities or objects, and association is nothing but the relation in between the objects or entities. So there can be, in other words, association defines multiplicity between the objects, that is multiplicity means the relation between the objects or entities. There are various types of relationships, as we already know. They are one to one, one to many, many to one, and many to many. All these are different types of associations that can be established in between the objects or entities. This association has a one special feature which is called as aggregation. Aggregation is a special form of association. This association is a special form, or aggregation is a special form of association. Also, composition is also a special form of aggregation. For aggregation, there are two things to be known. What are those? Aggregation is a special, for association there is a one thing to be known which is called as aggregation and composition. What is aggregation and composition? Let us now discuss with an example. For example, consider a student and faculty having an association. In between a student and the faculty, we have a association, that is a relation. Between student and the faculty, there is a relation. So now coming back, what is aggregation? Now let us discuss about aggregation. Aggregation is one of the special property of association. It is a special property of association. It is a directional association. It shows, it is being represented with the help of the direction which is represented in the below diagram with a line followed by a diamond symbol or a rhombus symbol. This is the representation of an aggregation, and it is also called as has a relation. It is also called as has a relation. That is called as aggregation. About this aggregation and composition, in the next slide, we will discuss with an example. Before discussing about the example, let us also know what is composition. A composition is also a special case of aggregation. Composition is also a special thing of aggregation, in that it is more specific. That is, in composition, a restriction is being placed on aggregation. Aggregation, if we place a restriction on the aggregation, it is called as a composition. What is this restriction and how can it be placed? Let us discuss it in the next slide. Now for that, let us consider an example. Let us consider an example. A class contains students. Consider a class with number of students. Here, a student cannot exist without a class. That is nothing but the student is being restricted, that he cannot exist without a class. That is the more restriction that is being placed. This restriction is called as composition. So composition here is more restrictive than aggregation. So what is the difference between aggregation and composition? The composition is very restrictive. That is, the student cannot exist if there is without a class. A student does not exist without a class. There I am placing a restriction on the student that he cannot exist if there is no class. That restriction is called as composition, which is more and more restrictive. Wherein which in aggregation there is no restriction. In aggregation there is no restriction. When there is a composition in between two objects or entities, the composed objects can exist without the other objects. Without the other objects. In composition there is restriction, wherein which in aggregation there is no restriction. This restriction is not there for aggregation. That is, one object can exist without other objects. But in aggregation, in composition, definitely second objects will exist only with the help of the first objects. That is what I have written. The existence of the composed object is entirely optional. In both aggregation and composition, direction is must. The direction specifies which object contains the other object. The direction specifies which object contains the other object. Now another example. Consider an example in which I am going to consider three entities: library, students and books. There is a relationship. Now consider the relationship between library and students. It is aggregation. It is aggregation. Means there is no restriction between library and students. If a student wants to go, he will go to the library and read the books. There is no restriction on the students, which is called as aggregation. Now consider again the relation between library and books. Library and books. What is the relation between library and books? It is a composition. Why is it called composition? Because books exist only if the library exists. Books are present only in the library. So books will exist only if the library exists. That is, here I have been placing a restriction on the books. That is, the book entity exists only if the library entity exists. That is called as aggregation. Wherein which in the first line I have written library and students. Student can go or he may go or he may not go to the library, which is called as which is not aggregation. So here a book cannot exist without libraries and therefore it is called as composition. For easy understanding only I have taken in this example and don't go into the deeper and make a mess of this example. Followed by the next topic to be included as entity clustering. The next one to be discussed is about entity clustering. What is entity clustering? Again, this clustering is always is being defined from the specialization and the generalization process only. An entity clustering is a useful way to represent or present the data model for large and complex organization. If the database is very big, we can use the concept of entity clustering to represent it in a better way. The entity cluster, it contains a set of one or more entities that have association or relation within themselves. An entity cluster is nothing but a set of one or more entities which have relationship within itself. A clustering is a hierarchical decomposition of the data model. It is a hierarchical decomposition. And in the entity clustering, generalization or specialization is a process of defining the entity clustering. Generalization and specialization is a process of defining one or more entities from a set of specialized entities. For this again I am going to consider the example of specialization and generalization only, in which I have considered three entities: car, truck and motorcycle, among which the three entities have some common attributes: vehicle ID, vehicle name and vehicle price, and in which I am going to separate them and I am going to define a general entity vehicle which is being represented like this diagram which I have already previously discussed: a car entity with its attributes, a truck entity with its attributes and the motorcycle entity with its own attributes. If we look over that carefully, there are vehicle ID, vehicle name and the price being repeated in all the three entities which are being separated and being placed in this diagram. Considering a supertype entity which here is called as an entity cluster. This is called as an entity cluster. Vehicle with its specialized attributes, vehicle ID, price and name, followed by its subtypes car and truck which inherits its own, which are being having its own attributes. This is about entity clustering only, and this is the module summary in which I have been telling about the definitions of generalization, specialization, attribute inheritance, multiple inheritance, aggregation, composition and entity clustering. Thank you all.